Hello, Alvin ISD Geometry students. In this video, we're going to talk about probability with combinations. You should have already watched the probability with permutations video. If you have not, you're going to want to go back and do that one before you watch this video. Combination. A combination is an arrangement of objects in which order is not important. As you learned in the previous with permutations, it's an arrangement of objects, but the order is important. So this time, the order is not important. With combinations, the number of combinations of n distinct objects taken r at a time is denoted by sub n c sub r and is given by n cr is equal to n factorial over n minus r factorial times r factorial. An example would be the number of combinations of 8 objects taken 3 at a time. In doing that, we would see that 8 objects taken 3 at a time. So it's 8 factorial over or divided by the difference of 8 minus 3 factorial times 3 factorial, which ends up being 8 factorial over 5 factorial times 3 factorial. Remember in the previous video, we found out that 8 factorial really meant 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 until you get all the way out. In this case, we only went to 5 factorial, so we said 8 times 7 times 6 times 5 and left the factorial. That way these two could cancel since I knew that I had a 5 factorial in the denominator of my fraction. And then 3 times 2 times 1 gives me 6, so if I just multiply that out, then these 6's would cancel and these 5 factorials would cancel, which leaves me with 8 times 7 or 56. Again, if this isn't making much sense to you, you really need to go back and watch the permutation video before you move on. Here's our first example. For her birthday, Monica can invite 6 of her 20 friends to join her at a theme park. If she chooses to invite friends at random, what is the probability that friends Tessa, Guido, Brendan, Faith, Charlotte, and Rihanna are chosen? Okay, to start, since the order in which the friends are chosen doesn't matter, the number of possible outcomes in the sample space is the number of combinations of 20 people taken 6 at a time. So first we're going to find out the number of possible outcomes. So we could say 20 factorial over 20 minus 6 factorial times 6 factorial. Do the calculations, we end up getting 38,760. There is only one favorable outcome, so there's only one time that these 6 friends could be chosen, since the order that they're chosen isn't important. So that would be 1 out of 38,760. Here's our next example. If 3 points are randomly chosen from those named on the rectangle shown, what is the probability that they all lie on the same line segment? So in other words, what's the probability that if I pull 3 of these, randomly choose 3 of these points, that they're either going to be on side AC, side CE, side GE, or side AG? First thing I would do is start with my combination formula. So I have 8 different points and they're checking for 3 of them on a line. So that means I'm looking for sub 8C, sub 3. Once I have my n and my r values identified, so n being 8 and r being 3, then all I would need to do is substitute in those values. When I do that, I get 8 factorial divided by 8 minus 3 factorial times 3 factorial. So then doing my next step, I would say what that means is 8 minus 3 is really 5. So I have 8 factorial divided by 5 factorial times 3 factorial. Knowing that I have a 5 factorial on the denominator of that fraction, I would break apart 8 factorial to where it's 8 times 7 times 6 times 5 factorial. I stopped at 5 because I knew I had a 5 factorial on the bottom. Purpose in doing that is so those can cancel. So there they are. I've canceled them. Now I'm going to break that apart after I've canceled, or rewrite it after I've canceled it. So that's really 8 times 7 times 6 divided by 3 factorial, which in actuality is really 8 times 7 times 6 divided by 3 times 2 times 1, which if I do my multiplication, I would see that that's 56 over 1, or 56. Now, I found the number of combinations that I would have. After that, I can see that since there are 4 different sides, there's 4 different times that that could occur. So that would be, the probability of that happening would be 4 out of 56. And after I simplify that, I would see that that probability would be 1 out of 14. Here's our next example. 500 boys, including Josh and Sokka, entered a drawing for 2 football game tickets. What is the probability that the tickets were won by Josh and Sokka? So I've got 500 boys, that's the number of objects, and 2 football game tickets. So the first thing I would do is write my formula. I've identified 500 would be my n value because it's the number of objects, and 2 football game tickets, so my r value would be 2 because I'm taking them 2 at a time, since we get 2 tickets. So I would substitute in all my values. So I've got 500 factorial over 500 minus 2, because that's 500 minus 2, factorial times 2 factorial. Simplifying that, I would really just have 500 factorial over 498 factorial times 2 factorial. Well, I want to cancel as much as I can, so I'm going to decompose this 500 factorial, factor it out, I guess you could say, to 498 factorial. So I say 500 times 499 times 498 factorial. Leave the factorial, that way these 2 will cancel. Once I've simplified that, I have 500 times 499 over 2 factorial, which is really 500 times 499 divided by 2. Whenever I do that, I have, I can simplify the 500 by 2, so I have 250 times 499, which is really 124,750. And since there's one occasion when these 2 boys, Josh and Sokka, could be picked, the probability of that happening would be 1 out of, or 1 over, 124,750. Here is our last example. Rita's going on a road trip across the U.S. She needs to choose from 15 cities where she will stay for 1 night. If she randomly pulls 3 city brochures from a pile of 15, what is the probability that she chooses Austin, Cheyenne, and Savannah? I'm going to start with writing my formula. Before you go on, go ahead and stop or pause the video and see if you can determine what the n and the r values are. Hopefully you decided that my n, or the number of objects, was 15, and the number of them being pulled at one time was 3. So my n is 15 and my r is 3. Hopefully you did that. substitute everything in. And then if I were, I'd go ahead and pause the video again and see if you can come up with an answer from there. Okay, so once I've done that, I would break down the 15. 15 minus 3 gives me 12. So I know I want to take that 15 and factor it until I can come to 12 factorial, since it's the biggest factorial I have on the bottom. So that gives me 15 times 14 times 13 times 12 factorial. Stopped there. That way these two guys can cancel. That leaves me with 15 times 14 times 13 over 3 factorial, which is really 15 times 14 times 13 over 3 times 2 times 1, which if I go ahead and multiply those out, is 2,730, divided by 6, or 455 different combinations. Now, since this is one of the times that could happen, since the order doesn't really matter, that would be 1 out of 455. Thank you.